My name is Mr.Cáceres. I'm a PhD student with the department. I'm also the vice president of the Graduate Association, and I'm also an assistant professor at UCN Chile. So today is the first day of a 3-day session of CPLEX. Today we will be talking about CPLEX Optimization Studio, and on the following days we're going to be talking about how to use CPLEX with Java, so everybody can just write their own programs using Java inside of them. And I encourage everyone to visit the website and join the community. And we will be needing some files from this website, so later on we're gonna have to go there and and retrieve some Excel file and Access file to develop some of the examples. So just go there and join the community, and you'll also will get updates of events. You can see also I'm gonna leave all the code there as well, and this video is gonna be posted there as well. So what is CPLEX? CPLEX actually, I mean, the real name of the software is IBM iLog CPLEX Optimization Studio. CPLEX stands for the simplex model, and it's because it was implemented on the C language. That's why the C in CPLEX. And then this company, CPLEX Inc., got bought by iLog, and then iLog got bought by IBM. So that explained the whole name. So the CPLEX Optimization Studio is divided into 4 parts. It comes with an optimization programming language, OPL, which we use to write the mathematical models. And it comes with the integrated development environment, which is the actual software that we're going to be working on, and include the CPLEX engine and the constraint and the CP engine, which are for mathematical programming and constraint programming respectively. We will be working with the mathematical programming engine, CPLEX only, and what I want you to realize here is that you actually deal with the IDE and OPL rather than using CPLEX, which is the engine. The engine is behind everything, so you actually use CPLEX Studio to communicate with the CPLEX engine, and we're going to see in the following sessions how to build programs that also communicate with CPLEX. But you don't ever actually talk to CPLEX directly. If you have CPLEX installed in your computer, you can also use it through MATLAB and other software. But we will be using the CPLEX Studio, the version 12.6 specifically. Okay, so let's just get started with an example and see how we would go about programming this problem. So this is a simple minimization problem, really small. And here on the side I have the CPLEX Optimization Studio. When you first open the software, you will see this window. You can actually just dismiss it. We will be writing here in the middle all the code, and here on the side we will be managing all of the different files and projects. So to get started, we will create an OPL project. A new OPL project, you just right-click on that box and create a new OPL project. We're going to name it this is the day 1, example 1. And we're going to create just a model associated with it. Okay, so let's just verify that box with create model, and that would be it. Okay?
Should we create data too?
For this one, we're going to just use just the model, right? So we don't create anything else. Okay, so the first example is really simple, and we first are going to start by defining the variables. And a variable, decision variable, is declared by writing up the var and then saying what kind of decision variable it is. In this case, it's a float positive, meaning it's a real number for the continuous case. We're going to call the variable x, and the same thing for the variable y. I'm going to also define expressions. In this case, just one. I'm going to define the expression, which is going to be also a real number, and I'm going to call it cost. And that's going to be the cost of the minimization problem, which in this case is 0.12x plus 0.15y. All right. And now we're going to write up the model, the actual model. So this is minimization problem, so we write minimize, and we're going to be minimizing the cost, which was defined previously. And this is going to be subject to a set of constraints. And we're going to be naming the constraints. So first it's going to be cons of 1, and then we write up the constraint 60 plus 60y, that's greater or equal than 312 constraint 2 and constraint 3. Constraint 3 is 10x plus 30y. This has to be bigger or greater than 90. Made a mistake here, is 36. All right.
I just have a quick question. Actually, we don't need, if I don't write the constraints of the one, do you think any problem?
No, it's not necessary to write up the name of the constraints, but we're going to see why it's convenient to have it named. Right? Okay, so the problem should be this should work already. So we need to create a configuration in order to run this. So let's right click on run configuration, create new run configuration. Okay, and we're going to name it configuration 1, and we're going to drag the model into the configuration that we want to run. Once it's there, you just right click on the configuration and click on and run this. Okay, so the model was solved, and here on the side you're gonna see the values. You have here the decision variables y and x got the value 2 and 3 respectively, and with the cost, the total cost 0.66, and you have here also the 3 constraints. And you have to verify that this was actually an optimal solution. And so if you go to the, where is it? If you go to the solution tab down here, if you go to the solution tab, you should be able to see that a solution was found and that is optimal. Okay, this is relevant because here on the side, if the problem wasn't solved, you're still gonna see some numbers here. So to play with that, let's try something. This is a minimization problem, and by the space that we have defined here, if you change the objective function to a maximization problem rather than minimization, in the graph you can see that it's going to be unbounded. So what we're going to do here is find out how CPLEX tells me that it's unbounded. So I change it to maximize, and I run it again. And now the engine log tells me that the problem is unbounded. On the engine log, you can see that CPLEX tells you that the problem is unbounded. And here on the side, you still see that the variable y and the variable x took some value. Right? Okay, let's do something else with this. We're gonna learn how to do post-processing. We're gonna tell CPLEX to do something after solves the problem. So we're gonna do that by writing right after the model. And this is gonna be post-processing. Post-process. And okay, so to write a post-processing after the model, we write execute right. So I wanted to do something after solve the model. So let's say I wanted to know what are the reduced cost and the dual variables for the constraints. And I wanted it to do this if the problem got solved. So I'm going to write if CPLEX dot get CPLEX status. The CPLEX status, if it's 1, means that a solution was found and that is optimal. So in that case, only I wanted to give me the information of the reduced cost of the variables and the dual variables of the constraints. So for this, I'm gonna write a text reduced cost of x, and then so x dot reduced cost gives me the reduced cost associated with that variable. Just copy this, do the same with y, change it here, and now dual variable. Dual of const of 1. And here's where it is useful to name the constraints, because you can actually reference them from here. So from constraint 1, I wanted to give me the dual value. And we're going to do the same for the other 3 constraints. All right. And okay, that's if the problem was solved. If not, if a solution if an optimal solution wasn't found, then I wanted to tell me that an error was, then an actual solution wasn't found. So we're gonna write up else, and here we're gonna write okay. Right?
I just have a question. If I didn't name the constraints from 0, 1 to 3, but I name it differently, do they still, with the recipient still record?
As long as you name them, you refer to the same name down here. Doesn't matter what you write in here, because this is just text. Whatever is there with that color there, it's just text. You can write whatever you want there.
Yeah.
You don't even.
Constraint 1 is not 0, 1 is still okay. Constraint 1, constraint 2.
No, you can put whatever here.
Oh, I see.
Okay, I'm gonna name this another name. This is gonna be constraint hello, and this is, so here I also have to refer to constraint hello. All right.
Yeah, as long as they are good, unless they are consistent, it's okay. Right?
Yes, they have to have the same name. You have to use always the same name. All right, so if we run this, in order to see okay, so in this case, well, it is with the maximization, so it's not going to find a solution, so we're going to change it to minimize. Okay, so now there is minimization. I run it, and there it is. In the scripting log, we have what we wrote. We have the reduced cost of x and the reduced cost of y are both 0 because they are both on the basis of the solution. And we have the the value of the dual variables associated with the constraints. All right?
I have a problem. It's curious. What? You said that this version is because they're not updated.
All right. Make sure that you have all of the every time you finish a line, it has to have that dot and comma. I don't know the name in English. All right. So let's move on to the next one. Did it work? Did it work?
No, I had a problem. Let me just check because we didn't.
Okay. Let's do the second, okay? So for the second problem, I'm gonna explain what this problem is about. We have we have different cargo that we wanna ship in a airplane, and the airplane has 3 different compartments: front, center, and the rear. And for each compartment, there's a total weight capacity and also a space capacity. And for each cargo, we have a weight available to ship. a volume, and a profit. So we want to know if we want to know how much cargo we need to put on each of the compartments, and for that, so this is how the problem would be modeled. We have maximization of the profit. Xij here represent the amount of cargo I put into the compartment J. First constraint is about the available waste to ship. Second constraint is about the capacity of the compartment, and third one about the space capacity of the compartment. And the last one is a constraint that is there to make sure that the plane is balanced. So the proportion of the different weight on each compartment have to be the same, so that the plane flies. Flies well. That's a constraint that is on the problem as well. So we're gonna model this. For that, we're gonna create a new model. Excuse me, a new OPL project. So we create a new OPL project. And in this case, we're gonna have to use data from Excel. So we create also a data a data file. Okay. So let's translate that to the model. Okay, so first I'm gonna write some parameters. I'm gonna define n as the total number of n is gonna be number of cargos. And m is going to be the number of compartments. I'm going to define range. Later on, you're going to see why we need to define the ranges. So it's going to go. It's going to contain all of the cargos, 1 till n, and another range for the compartment, 1 to m. And I need the variables. I need the parameters for the profit, weight, and volume of each cargo. So I define those arrays. Just profit. So and that gets defined for all the cargos, and the cargo is arranged from 1 till n. And when I write these 3 dots here, means that I'm going to be getting that data from somewhere else. We're going to see how we're going to do that. There's no need to put the float there as a plus sign, because these are going to be read from the file. So that's going to come with the, that's going to give it the if it's positive, negative. And now for the cargo, for the compartment, there's the weight capacity. And the space capacity. So now we need the Excel file. If you go to the website, you can get the files from there. Okay, so this is the Excel file. And you need to position this Excel file in the same folder as the project is. So if you go to this, if you right click on the OPL project and go to properties, you're gonna see the location that you're using for that project. Just copy it and go there, and you take that file. You need to take that Excel file there. So if you go back to the project, and you refresh here, you will be able to see it there. All right. So now I'm going to the data. I have the model. We're gonna hold on to that a little bit, and then we're gonna go now to the data, and right there, how we're gonna get the information from Excel. So first, I'm gonna say that n is 4, which is the number of cargos. That n is 3, m is 3, and I'm gonna create a connection to Excel. And I'm gonna call it my cheat. And I need to refer to the exact name of the file. Okay, so what I'm gonna be reading from there All right, so I have the model here on the side, on the left side, and on the right side I have the data. So I need data for profit, weight, volume, weight capacity, and space capacity. All right, so profit is going to come from. So in order to know where it comes from, if you open the Excel file, if you open the Excel file, you're going to see that profit is here. All right, so profit is there. So cheat read, we're going to use the connection we created, and we're going to refer to the exact range in the Excel file. So you can write the name of the sheet is LP example, is right there on the bottom. LP example. My sheet, yes. LP example, exclamation point, and yes, the range is H2, till age 5, right? Now, this is really inconvenient. I mean, you have to write the name of the cheat and the exact range. And this is really hard to like read here. I mean, if somebody else sees this, this is hard to read. So I actually prefer naming the ranges on the Excel file. So for example, here, this range, I named it profit. It's right there. So you just click here on the top and put the name, whatever name you want to create the range of. So each one here has a name that you can refer from here. So instead of writing the range there, I'm just going to write profit, which is the name of the range which contain all of those values. Okay, and that way it's more readable. And I need that for weight. And volume. And the same goes for the compartments. Space. All right. Okay. So that's with the data. That's how we get the data from the Excel file. Now let's continue with the model. So in the model, before writing the model, we actually need some variables, decision variables. So the decision variable is going to be a float, has to be positive, and we're going to call it x, and x is defined, I is cargo and j is compartment. So first is cargos and compartments. And there's one more variable, y, and that's it. Okay, make it positive as well. This is maximization problem, so maximize, and we're going to be maximizing the sum over I and j. So I is part of the range cargo, and j for all of the compartments, and that's the sum over profit multiplied by x. So it's going to be profit of I multiplied by x I, J. Right? This is going to be subject to okay, so the first constraint is for all i's in the set A. So we write that this way: for all I in cargos, which is the set A, and we're going to name these constraints. We're going to name them. This is for the available cargo to ship, so we're going to call it available weight. You can name it whatever you want. So this is going to be the sum over J and this is just the summation of the xij, so xij, and this has to be less or equal than the available weight. The available weight, the total available weight for that cargo is this value, so we write weight of I, right? And that's it. That's the first constraint. Second constraint, similarly, in this case is for the J's. This is for the I'm gonna call it the weight capacity. The weight capacity. And this is gonna be the summation over I cargoes. This has to be less and equal than the weight capacity of the compartment. So this is represented by weight cap J. Right? And I'm making a mistake here. Okay, yes, it's the summation over the xi. Yeah, I'm not putting the variable. Forgot to put the variable xij. There it is. Third, the other constraint then is for the space of the compartment. For all B's and cons, B space capacity. It's going to be the summation over all cargo within a compartment. So in this case, I have to take into account the volume of the cargo. Volume I, next I, J. So this has to be less than equal than the space capacity of the compartment. And finally, to maintain the airplane balanced, this has to be equal to 1. To write equal, we need to write it twice. Alright, so that's our problem. And let's try it out. So in order to run it, we need to create the configuration, create a new configuration. We're going to drag the model and drag the data that we're going to be using. And right click on the configuration and run it. Okay, let's see what we have here. So on this side, there's the solution. You can see here the value of the parameter that we got from the Excel file, the value of the decision variables, and the constraints. Now, if you put the mouse here on top of X, you're gonna see this this button right here to see the details of the variable right there. So if you click on that, you're gonna be able to see in this window what value took each variable. So for example, x21 takes value 10, it has a reduced cost of 0, okay, and it gives you also a sensitivity range for doing sensitivity analysis. And you can do the same for example, the weight for the constraints. You right click on it, you're gonna see if there's some slack in the value of the dual variables for those constraints that don't have slack. So you can see here, for example, the available weight, there are some slack there and no dual variable, of course. All right. Now, I find this to be a bit inconvenient. We'd use numbers to refer to the compartment and to refer to the cargo, whereas in real life they have an actual name. The compartment is the front, the center, and the rear compartment, and the cargo, each one has one name: C1, C2, C2. So why don't we just use those numbers? I mean, use those names instead of having to use numbers, because that would make the solution readable. Here would be nicer if we had C1 and say here, instead of 1, saying front. That would make it more readable. So let's do that. Wait. No, I need to do something first. Some other stuff there. I want to write the solution in Excel. Yeah, let's do that first. Write up the solution in Excel. So let's say I want to store the solution in Excel here. I want to store here the value of X. X is IJ, cargo compartment. So cargo is on the rows. So I'm gonna make this table here. And here I'm gonna tell CPLEX to store the results in that range. So I'm gonna name that range. I'm gonna name it results. And on the data file of the model, I'm gonna write X I'm gonna write X to cheat right. Okay, and that's on my cheat, and the range of the name of the range is results. Alright, so before running this, you have to close the Excel file because CPLEX is going to write on it, so it needs to be closed. You close that up, and then you run it again. So let's open the Excel file. Yeah, the problem got solved. Let's open the Excel file and see what we got. And there it is. Now we have a matrix with the values right there. All right. Okay, there's some other inconvenience about this way of working. I mean, working with a spreadsheet, what seems to be like really convenient, but if I wanted to add more cargo, I would need to add it here. I would need to add it here also, rename the ranges, and then go again to the model and run it again. If I were to put, for example, more compartments, somehow you can put more compartments in an airplane. You would put it down here, and you have to rename all of the range every time before running the CPLEX again. So we're going to use another technique of doing this by using databases. In this case, we're going to be using Access. And we're also going to be modifying the indexes. We're not going to be using numbers. We're going to be using the exact name as index. All right, so in order not to mess up anything that we've done already, let's just create another model within the same project. So you right click on the OPL project and go to a new model and create a new model. Let's just create a new model, and it's going to be day 1 example 2 version 2, right? All right, so this is a new model, and we are going to write it up all over again using a different syntaxes. We're going to see how that's going to be different. All right, so I'm going to define a set of strings which is going to contain the names of the cargos, and we're going to be doing that this way. So this is a range of strings, and I'm going to be reading that information from somewhere else. And that is going to contain, it's going to be the cargo names. And the same goes for the compartments. All right. I'm going to create a special type of variable, especially for the cargo, which is going to have some properties. Let's just write it up and see what it means. So I'm going to define cargo type is going to have a float, which is going to be the available weight. Float, that is going to be the volume per ton, and another float being the profit per ton. And I'm going to be doing the same thing for the compartments. The compartment has two properties, the weight capacity and the space capacity. So I'm going to use now those definitions, and I'm going to create an array that's going to contain that information. And I'm going to call it carcass data. I'm going to be reading that from somewhere else. The same for the compartment. All right. Now I'm going to need that access file, so I go to the website to get it. It's here. Yeah, put it on the same folder. All right, so we're gonna need to create another data set, another data file. So we right click on the project and create new data. And this is gonna be okay, so new data. We're gonna be using the access connection now. If we take a look to the access file, we will see that it contains three tables. The cargo tables, the compartment table, and the results. Okay. Okay, so first let's create a connection. We're gonna call it DB. It stands for database. You can call it whatever you want. And I say this is gonna be an access file, which name is data. No, what's the name? That's the name. And the extension of that file is ACCDB. Okay, there the connection was created. And we're gonna collect the parameters cargo and cargos data from database called db, and we have to write it here in SQL language. So this would be select, and we're gonna be recovering the name, the weight, the volume, and the profit from the table cargos that is on that database. Right? Alright, so one thing that have to be clear here is that if you see here, you can see how cargos only has one dimension. It's just gonna have the names, and cargos data has 3 dimensions. Okay, and then the order in which I put the cargo there, cargo data second, this order has to be respected, has to be the same as those variables. So first the name is going to be captured by cargos, and cargo has only one dimension. So the rest is going to be allocated to cargos data, and that's going to be the weight. It's because first written there, the volume second, and the profit last. All right? And let's do the same for the compartments. It's going to be comps and comps data. That's going to be read from db read connection db. It's going to be, we're going to select the name, the weight cap, the space cap from compartments. Now, these names here have to be the exact same from the tables in the database. All right, it's not just any name; it's the headings of the tables on the database. Okay, so have to match those names there. All right, so that's the data from Access. Let's keep writing up the model. So let's define variables. And I'm also going to define some expression. All right, so let's see what I just wrote. Uh, what's wrong here? Profit per ton, I and cargoes. Okay. Oh my god, I wrote this wrong. This per ton. There it is. All right, so that's the total profit. It's the summation over i's and j's. And here, so this is interesting. I have the array cargo data, and I call one of its property by putting a point after and calling the property, right? So that's total profit. And we're gonna define another one, expression. This is gonna be space used per compartment. Space used, you can name it whatever you want, but this is gonna represent the space being used at each compartment. But this is a space used per each compartment. So this is gonna be an actual array. So j, I'm gonna write it like j is in const because it's one for each compartment. Okay, the space used per compartment is going to be defined for each compartment. So this is the sum over. So I'm going to make the summation of all the cargoes that are in that compartment. And this is space use, so I have to refer to the volume. I'm going to use from the data set of cargo I, I'm going to call the volume per ton, and that's going to be multiplied by x ij. Right? And let's do another similar one. This is going to be the weight used per compartment. It's also going to be defined for each j. It's going to be the sum of I in cargos. And also I'm going to be taking that from cargos data. But in this case, I'm going to use the no, I don't need to use data because x actually represent weight. So it's just a summation of x ij's. Let's write the model now. So it's a maximization problem. Let's see. And we're gonna be maximizing total profit. This is gonna be subject to subject to. So basically are the same constraint we were using before. Okay, so that's for the first one. So this is where I use the expression that we created up here, the space used per compartment. So that's the space used per compartment has to be less or equal than the total space available. So comps data for that same compartment, the space capacity. So defining expression actually makes it easier to write the constraints, and it makes them readable. Let's do now G and comps. This is going to be, we're going to call it so we use the weight used per compartment has to be less or equal than the capacity that each compartment has. And now for the balanced plane constraint, we're also going to use the weight. That has to be, since the proportion has to be divided by the weight capacity, has to be equal to y. Alright, so basically we just, and I forgot to name this constraint. It's always desirable to name all of the constraints, because then you can refer to them and you can easily read the solution, as we're going to see now. So we're going to create another configuration in order to keep the previous one. So this is going to be configuration 2, and for this I'm going to use the second version of the model. I'm going to drag it into the configuration, and the second version of the data file, which is this one, I'm going to drag it into that configuration, and I'm going to right click on the configuration and run it. So let's see here. So now we can see here the solution. All right. And this is what I want you to notice now. If you go now to the x variable, instead of seeing x1 or something, you actually see the names. C1 on the front, 0. C2 on the front, 10. Right? That's more readable. Right? And it actually makes it easier to modify the data. So for example, I can just go here and add a cargo 5, which I have 10 of this, uses this volume, and has this profit. I add it there, and I go here and I run it again. And if we see, we go to the solution, and we're gonna see it here. Now it's C5 is right there. So that was easy. All right. So let's now write this result into Access in order to use those results for later analysis. All right. So we just go back to the second version of the data file. Where is it? It's here. All right, so we're going to be writing the results in this table, which has three columns: the cargo, the compartment, and the amount allocated to that compartment. All right. So we actually need to create a variable which has those three dimensions, because X doesn't have three dimensions. X has two indexes and its value, the value. So I'm going to create a special variable that is which is going to contain the result. So I'm going to create a type of variable that we're going to name it result, and it's going to have a string which is going to be the name of the cargo, another string which is going to be the name of the compartment, and it's going to have a float which is going to be the amount allocated, the amount of that cargo allocated to that compartment. And I'm going to fill this variable and this other variable called results, which is going to be a set of, it's going to be the combination of the i's of the j's and the xij. So it's going to create all of the possible combinations of those. And I have to add that the i's have to come from the set cargos, and that the j's have to come from the set coms. All right. And what I'm missing something here. Let's see. All right, I made a mistake. I'm writing on the model that I shouldn't be writing. So I'm gonna take all of this code. This is on the second version. I should have been written this. Okay, so second version, I'm working on the second version. My mistake. All right, so now it works. It's just fine. Now I have a variable which has three dimensions: string, and the amount. All right, cargo, component, and amount. So, and that I have to send to the access. I go back to the data file and I say that the variable results has to go into so db, and I'm going to be update the database, and the update is going to be an SQL statement: insert into results. Result in this case refers to the name of the table in the access file, and I'm going to be writing in these columns, and the columns cargo, compartment, and the column amount. Which values? So since the values are going to be given by the variable results, here we're going to write it as question marks, which in SQL means that that the method is going to be reading in that order the values. The only thing that you have to be careful here is that this variable has three columns, 3 dimensions, and is in the same order here, and you have also to have 3 question marks for each one of the values that are stored in that variable there. All right. So if we run it and we go to the access file, wait, something didn't work here. I have an error. Okay, I wrote this wrong. It's DV there. DV update. Okay, and I'm running out of battery. All right, there it worked. So I go back here and I refresh and I see all of the results. Now, I wanted you to see that if I run it again, this is going to keep inserting the results in the table. So if you refresh this, you're going to see this, the same again. So we got to write something else before this. And we're going to execute some command, dv execute. And it's going to be dv. We're going to, so before writing the results, we're going to be deleting the complete table. Okay, so if I run it again, then I refresh this here. I did finish. There. So now it only is going to contain the last result. All right, so that concludes the example 2, and we run out of time. We arranged for a follow-up session that's going to be next Friday to continue with the last example, what's mixed integer programming, about the travel assessment problem, but we're going to do it next week. So that's all for today. And feel free to go to the community website and post questions there, and we're going to be answering whatever doubts you have or whatever problem you've encountered. So feel free to post anything there, and thank you for attending.